Next, we're going to talk about encoding memories. So this is the first of our 3 steps: encoding, then storage, then retrieval. So encoding memories is that initial process. How do we form a memory code? So how do we initially learn that information? And you're going to find that there are a couple of parallels here, especially with our talk of, say, cognition, as well as sensation and perception. We're starting to make connections with some of our earlier chapters. But if you think back to the sensation and perception chapter, we talked about a concept called transduction, where we took stimuli from our environment, they interacted with our sensory receptors, and they were turned into some kind of neural code that could be brought to our brains in order to be processed and perceived. Encoding is the same basic concept, where we look at information that's been brought in from our environment, and we're turning it into some kind of memory code, something of meaning that we can store away for later. So this is how we're taking information from our environment and turning it into something that could be stored in the future. So encoding is we're turning it into code that we can remember later. And sometimes you'll see people talk about the issue of the encoding problem. So how do our brains obtain the information that they're going to store later for retrieval? How do they decide what is important? How do they decide what we're keeping and what we're ignoring? So sometimes you'll see it referred to in that way. So in order to initiate this whole process, in order for something to become a memory, to be put into storage and retrieved later, we first have to get past that first hurdle of turning it into something that could be stored later, or stored for later. And so the first thing we want to look at in terms of encoding is our sensory memory. So sensory memory is the system that keeps information translated by our senses in a briefly active form, it keeps it briefly active in an unaltered form. Whew, words today. But this is basically saying that when we're bringing information in from our environment, we aren't necessarily perceiving or paying attention to absolutely every stimulus that's coming in. We're hearing things in the background and we're filtering them out. We're ignoring them because they aren't relevant. Maybe we're feeling things that we don't need to be feeling, or smelling things that aren't relevant. So this is when we have that sensory memory. So we have information coming in, our sensory receptors have detected stimuli, and we're going to get to that point where we decide if we're going to be using that information for later. And so we can think of sensory memory almost as a buffer. So it's going to hold on to that information from our sensory receptors until we can decide if we're going to use it or not. So we have 2 big types of sensory memory that we talk about. The first is our iconic memory. So this deals with our visual sensory memory. So this is information coming in through our eyes. And we can call this, so icons would be the things that we are remembering very briefly from our sensory receptors in our eyes. And so this is kind of like when you're walking through the halls and you have a moment of, wait a second, what did that person's shirt just say? So you saw it, you didn't process it right away, and then as you were walking, you kind of caught up with your own visual system and went, wait, that was interesting or weird or attention-grabbing in some way. So you have that brief ability to backtrack to something that you had just seen to then figure out that, okay, now I need to pay attention to that. We also have echoic memory. So this is our auditory form of sensory memory. So we can think of sounds as echoes, where we hold on to that sensory information for just a moment. I know that I am really, really bad for this one. So maybe someone comes up to you and starts talking to you, and they started talking before you were paying attention. So you stop them and you say, wait, what? But as soon as they go to repeat, you know exactly what they said, because you sort of rewound the conversation in your head and you figured it out. So you relied on your echoic memory to kind of pull back the last couple of seconds of that process. And so this is really useful because we don't necessarily know that things are important right away. So this gives us that buffer time to figure out, okay, I need that information or I don't. And again, we're going to start seeing with memory that a lot of this stuff, we don't necessarily know exactly what's going on, hence talking about a lot of different theories, a lot of different concepts. So we're going to be focusing in on iconic and echoic memory because those are the two that are most well understood. So we're going to be sticking with visual and auditory information, even though we could theoretically have sensory memory for other senses. These are the two that we care about. But, okay, so we can say, yeah, that makes sense. We can tell stories where, we have a buffer of our visual information. We have a buffer of our auditory information. But how the heck do you study that? And so one of the best ways that we can do that is kind of like an experiment like this one on the figure here. So if we look at the first step, that's labeled as fixation. In a lot of psychological studies, this is basically there to make sure you're facing in the right direction and you're looking at the right place. You could theoretically do this with an auditory setup, but it's a lot easier to visualize with a visual setup, so that's what we're using here. So step one is have a participant and have them face and look at a particular point on a screen, usually done on a computer. Next, we have a display, an exposure to a bunch of visual stimuli. So here we have 3 lines of 4 different letters each. And so they could randomize the letters, you could include numbers, you could include a couple of different things here. Letters and numbers are the most common. So that would be flashed on the screen for just a fraction of a second. So here it's listed as 1/20th of a second, so very, very briefly. But entirely enough for our sensory receptors, for our visual receptors to pick up on that information. Then we would be asked, what did we see? And there's 2 different conditions. The first would actually stop after the display portion, and they would just say, report as many letters as you can. They might ask you to report locations as well, but we would find very, very quickly that we wouldn't be very accurate at reporting the whole thing. So a full report is not going to be accurate, and that might be some issues with our short-term memory. It might be some issues with our iconic stores. It's a little bit complicated there, but we're not typically good at full reports. So instead, most of the time, these studies will use something called a partial report, which is basically they introduce a tone, usually a high, medium, and low pitch sound. And so if they play a high pitched tone, they want you to report the upper line. Low pitched tone is the bottom line. And that way you only have to report a single line. So 4, in this case, just 4 letters, which is quick enough that, yeah, you could probably report everything that you had just seen. And so they would display this tone after a certain amount of waiting. So 0.15 of a second, 0.3 of a second, 0.5, or even a full second. And by varying how long you wait before they display this tone, we can look at how quickly your iconic store starts deteriorating. And so we find that we're very, very good at these partial reports. If we're only asked to report a single line, as long as it's less than a second. We're pretty good to sort of about half a second or so. And we see some variability here. But this tells us that our iconic store is going to be accurate at the level of fractions of a second. Anything longer than that, and we really can't hold on to that information accurately for any length of time. If we were doing this with an auditory cue, so if they set up something kind of like this using Audition, we're actually a little bit more accurate with our echoic stores for longer periods of time. So echoic would be in the range of like a second or 2. So iconic visual is fractions of a second. Echoic or auditory is going to be a couple of seconds, so 1 or 2. And I already kind of said this, but we're much better at those partial reports than full reports. And that's just sort of the mechanism of what we're being asked to recall at any given time. So there's lots of moving parts we can evaluate with one of these setups. So you could vary how many lines are there, how long are those lines, how many letters on each, and things like that, just to get at a specific of how much we can hold on to. And typically about 4 items per line is about optimal. And we'll kind of start seeing why in just a moment here. So of course, if we're thinking about encoding, if we're thinking about bringing things into our memory, we probably have made some connections already with our earlier chapters talking about attention. Things that we are currently aware of, things that we are consciously aware of. That's definitely going to affect what ends up being stored in our memory for the long term. So attention plays a large role here. If we are not paying attention to something, and if something is not salient enough to grab our attention, it's never entered into our conscious awareness, and we're very unlikely to ever remember it. So if we see something and don't register that we saw it, we're not going to be able to tell someone later about having seen it. And so when we were doing our chat about awareness and attentional blindness or inattentional blindness, we showed that video of people passing basketballs. So you might be able to recall the passing basketballs, but if I didn't sort of pause it and have it go back and they showed you the gorilla in the middle, you might not have remembered that part of it. You wouldn't have been able to report that that happened if we didn't bring it to your attention. So attention and awareness play a lot of a role here. And because we have that little bit of a buffer with our iconic and echoic stores, we can actually have a little bit of variability in when we decide or select what we do or don't pay attention to. And so there's a couple of different theories, and we won't go into too much detail on them. But the basic idea is that we might have early filtering or late filtering depending on the situation. And I'm actually going to scroll to this page here so that we can see the visual that goes with it. So this diagram is looking at sort of the progression from a stimulus coming in from our environment and then over to some kind of behavioral response where we might react to that information that's come in. And so the first step is sensory detection. Is it registering on our sensory receptors? Have our eyes seen that thing, or did our ears pick up on it? In the middle, there's some kind of recognition. We assign meaning to it. So that would be the stage of perception. So we've brought in information and now we've assigned meaning to it. And then afterwards, we would sort of decide what kind of a response is required based on that information. And so we have a couple of different models. We can classify them as either early selection models that would say once we've detected it, we would immediately decide if we pay attention to it or not. But there's also late selection models. So that would say that we have a filter that comes a little bit later. And this tends to line up really nicely with those ideas of iconic and echoic stores, where you can say, wait a second, I did just hear something, or I did just see something. Let's pay attention kind of back in time. So we can sort of have that shifting of where the filters go, where are we paying attention? And most of the recent evidence isn't going to say that it should be always early or always late. Usually it's somewhere in the middle. And we're going to find that consistently in this course, where there's usually 2 theories proposed and we find a happy medium, or at least a place where we can all agree to disagree. And so, yeah, we can have that decision of what do we pay attention to or not. Maybe you hear your name and it catches your attention. So you can sort of rewind back in your echoic store. What are they talking about? Is it something interesting? Do I want to pay attention? Am I going to react to it, or do I keep going on what I'm doing now? So that's kind of where this is talking about. So where do we decide if we pay attention or not? And if we do pay attention, then it can become part of that memory process. All right. The next section I want to talk about is our immediate memory. Now, this is another one of those places where there's a bunch of different terms and people tend to disagree on what terms they use and how they use them. I'm using the concept of immediate memory to refer to both our short-term memory and our working memory. Some texts might break it down into short-term memory as one thing, working memory as another, and talk about them completely separately. I have also seen texts that squish it together and call it short-term working memory, or STWM, all at once with no distinctions. So I'm kind of going with a middle ground. I saw the term immediate memory that is basically all of our systems that actively hold a limited amount of information so that we can do something with it. And it includes both short-term and working memory. I kind of like this term. So this is our more general description. Immediate memory is our big, broad category. We can also talk about short-term memory as holding on to things, holding on to information currently in order to sort of have them in our memory. Working memory is where you actually work with information. And we're going to revisit these topics a little bit more down the line. But working memory is where you would have information not just to hold it, but to do something with it. So just the distinction between the three terms. They're all very, very similar, but they have slightly different specifics. And we can think of our immediate memory as the contents of our consciousness. So again, back to the consciousness chapter where we would talk about our consciousness, our pre-conscious, our unconscious. So this is the stuff that we are actively thinking of in the moment. And so we can talk about three different characteristics of our immediate memory. So representation is looking at what kind of information that our system is holding on to. We can look at the duration, how long we can hold on to that information before we forget it. And then capacity, which is how much can we hold at any one time. So we're going to talk about each of these and how we can modify them or sort of make exceptions to each of them. But first, we're going to talk about representation. So what kind of information are we holding on to? And as I said, we're focusing in on auditory and visual stimuli the most because those are the ones that we've studied the most. Those are the ones we're most certain of. So we can talk about representation as an internal inner voice, almost like your own monologue. So if you were given a grocery list from your mother, you might say those items in your head to remember them. So if you have to go and get bread and milk and cheese, you might repeat those words to yourself, sort of an internal running monologue. We might also have visual information stored. So our inner eye. So instead of the words and hearing the words, maybe you see images. So you see a loaf of bread and a carton of milk and a chunk of cheese. Maybe that's how you sort of hold on to that information. And we can have other kinds of information, which we'll talk about a little bit more when we look at our working memory in particular. But these are the two big ones. For duration, of course, we want to know how long we can hold on to information. So how long can we remember that grocery list? And there's a bunch of research, and depending on how things are set up, there's a lot of variability in what people think is going on. So when we're looking at how long we can hold information before we forget it, it's going to depend. Again, so it can be as little as 3 seconds before we see a drop-off in performance. So after as few as 3 seconds, we can start losing items from a list that we were just given. And we can hold on to things for almost up to 20 seconds. 20 seconds is sort of that upper limit that we can hold on to something before we lose it. And actually, if we switch to this next slide, if we look at, so this graph is showing seconds between presentation and recall. So if you were given a list of items, or here they're talking about percentage of letters recalled. So if we had items flashed on the screen or whatever, and we would have, at the 3 seconds, we have pretty good recall. We can recall most of them. But at 3 seconds, you start seeing that drop off. We can still recall some up to about 20 seconds, but after that, there's basically no recall. So that's what we mean by saying there's sort of a variability there, where we start forgetting things after 3 seconds, and by the time we hit that 20-second mark, nothing is left. But there's usually going to be what's called a forgetting curve of how much we lose at different times.
So if you're like repeating those letters in the typo, would you be able to remember longer than 20 seconds?
Yes, and that's called rehearsal. So the process of rehearsal is where you repeat those things over and over again. So maybe you repeat your list, or you repeat the letters that you just saw. So in most of these studies, so in that graph here, they would be, basically they'd present you with something and then either distract you right away with something else or ask you immediately to report what happened. So if there's a 3-second delay, then maybe they'd show you something else that would keep you from rehearsing things in your mind. For a 20-second delay, they'd probably have you do a math problem or something like that. So they would time exactly how much of a distraction you had before you were then asked to repeat things. And so they have different tricks to keep you from rehearsing. But if you rehearse, you can hold stuff in your short-term memory pretty much indefinitely, which is kind of cool. And we actually have different kinds of rehearsal that have differing sort of effectivenesses. We have maintenance rehearsal. So what we've been talking about, where you just repeat the list over and over again, that would be maintenance rehearsal. So you just take that information, you maintain it in your memory by saying it over and over again. But I have still got the ability to remember our list, even though it's been more than 20 seconds. I still know that we were supposed to go and get bread and milk and cheese. And it's because I'm using elaborative rehearsal and I'm making connections with other bits of information. It also helps that I use the same list every year, so it's not so much short-term memory as longer-term stuff, but I make connections between things. So maybe I'm thinking about, okay, bread to make sandwiches, and milk to drink, and cheese to go on the sandwiches. So I'm adding extra information, I'm elaborating on my list, and it helps me remember it a little bit better. It also helps prevent you from starting to lose items as you get distracted. So that's a duration. And then the last one we want to talk about is capacity. So how much information can be held in a memory system at any one time? So how much can you hold in your memory at once? And there's a lot of disagreement, again, on this. So typically we'd consider it whatever you can rehearse in about 2 seconds. So if it takes you longer than 2 seconds to run through your list of items, it's probably too many things to hold in your memory for any length of time. So our capacity is going to be about 2 seconds worth of information. And typically we're going to see it referred to as 7 units plus or minus 2. So if you're remembering numbers, we would have about 7 numbers, or letters, 7 letters, or a grocery list, about 7 items. So units of information, 7 plus or minus 2. Some of us are on the lower end of that spectrum. I know 7 is a lot of things, and I am not good at that. I used to joke that my friend and I, watching us try and dial a phone number was the best 10 minutes of your life to get us to put the numbers in the right order. And it's because it took both of us to put the numbers in the right order. But we'd have a lot of trouble holding on to information. Some people are really great at it. Some people can hold information in large amounts and are great at repeating things, and they have a much larger capacity. I am not that person, which is unfortunate. But we can also refer to this capacity, or the number of things we can hold, as our memory span. So the number of items we can hold in that sort of 2-second recall ability. And of course, we can extend our capacity using different tricks. As per usual with memory, the more things we make connections with, the more meaning we can assign to something, the easier it is to remember. So we can use a process called chunking in order to group familiar stimuli in order to store them as a single unit. So if we look at the first line here, Those are groups of 4 letters. Those don't have any meaning associated with them. That doesn't help at all. Out of all of that, I might remember the last 4. I might remember best because that's a word that makes sense to me. So that's all I would retain from that list of letters. But if we grouped them a little bit differently according to meaning, so now we can group them into longer clusters of letters, but now they're words that have meaning, I only have to remember 4 words. That's not bad at all. That's not like 20 letters. That's just 4 words. So we can chunk things and cluster them together so that we can remember more information at once by using little mental tricks. And we'll talk about more of those little tricks when we come back to the topics as we move through the chapter.